was talking to someone from class yesterday, and they were like, "Hey, where's all the technical content? We're just looking at empirical papers." And yeah, so we were doing empirical papers just to get warmed up, and as an important prerequisite for doing any actual programming languages research, I think. But this week we are going to have actual programming languages papers, which we will talk about. And so we have here this paper on scope states, and then this paper on verifying determinism in sequential programs. And so the common theme here is type checkers. And so type checkers are astatic analysis, although sometimes people consider them separately. But for our purposes, yeah, we'll consider them static analysis. And so one of them is about a novel type checker and its application. And the other is about how to implement type checkers. And so let's talk about them a bit separately. Let's start with the application or the type checker. So this is verifying determinism in sequential programs at ICSE 2021. And it's something for the checker framework, which we'll talk about. And of course, Werner Dietl was a important architect of the checker framework. The idea here in this paper is that you have code and you think it's sequential, and you think, well, because it's sequential, it's got to be non-deterministic, but that's not true. It turns out that when you put stuff into a hash set, then the order of the stuff depends on the place where stuff is allocated in memory. And so you can run the same sequential program 2 times and you get different things. And so that has bad downstream effects. Like you have programs which produce different outputs in testing, and they really shouldn't do that, and that might give you flaky tests, which is a big pain. And so what we have here is we have this type system, which if a program type checks, then for the types of non-determinism specified in the paper, it is not going to have them. So it's going to be non-deterministic. It is going to be deterministic, which is useful. So you avoid some proportion of non-deterministic tests and other non-determinism in general in the program. Although tests are the instance where it's most likely to be an issue. It's also an issue when you're trying to debug programs. I did run into this problem like 20 years ago when we were working in the SIT program analysis framework, and I was like, oh crap, things are not actually deterministic. And so it's good to see that now there's a solution for it. We'll talk about the trade-offs with their solution. It's, I think, quite well motivated. It's a real problem that I've had, and I have the scars to prove it. It also has, okay, so the questions we want to think about when we're talking about things like this is, okay, what's a false positive rate? What's a false negative rate? Even if you have proofs, which this paper alludes to proofs, which are in the full tech report, it doesn't actually have the proofs. But okay, so you have proofs, and what do they actually guarantee, right? They guarantee something according to some model. And so is it good enough? So we should talk about that. And then the other question is, what is the annotation burden? And if you have a system that's going to work, except that the programmer has to write as much annotation as code, you don't have a system that works. And in this case, the annotation burden is high, and they have some argument about why it's acceptably high, but it is still high. So we'll talk about that. Okay, so yeah, that's the verifying determinism paper, which I think is an interesting paper and a good example of a type system paper that got accepted to ICSE 2021. All right, the other paper is an ECOOP 2021 paper, and in retrospect, I'm not so sure about having chosen it. So what is it? So it's like, okay, we're going to implement compilers, and when we implement compilers, we have to implement type checkers. And so this is an approach which they extend the scope graph approach to implementing compilers, and show that if you use scope states, then you can parallelize your type checker. And so they have a lot of reasoning, a lot of description of their algorithm for doing so, and some examples. And then they talk about the results they got on a implementation of their system on a couple of benchmarks. One thing I will point out about these two papers is that actually the non-determinism paper goes into quite a lot of detail thinking about parameterized types, and that actually makes their life a lot harder. And on the other hand, in the scope states paper, there's a lot of things I can talk about it, but yeah, there's some shortcomings. One of it is actually their sample implementation doesn't include parameterized types at all. It's like, oh, well, okay. We will talk about the benefits and the strengths and weaknesses of this paper more tomorrow, of course. My assessment is, okay, if you're trying to write a compiler, this is a useful set of techniques that you might have for writing a compiler. For those of us who are not actually writing a compiler, it's maybe not as useful to read this paper. Okay, what else do I have to say about this paper? It's kind of this implementation paper, right? It's like if you were talking about implementation of something that was not a key thing for building a compiler, then you wouldn't see it in a programming languages conference. But because programming languages people need to implement programming languages compilers, then this may be of interest to the readers of this paper in this venue. All right, so we'll stop there and we'll talk more about these two papers tomorrow. All right, see you then.